This video is for the domain and range from linear functions notes. Here's what the front side looks like. So we're going to start with equations and ordered pairs. So the first one says find the domain and range of the function f of x equals 2x plus 4, and to create a graph. So to create a graph, one thing that you can do in your calculator is you can go to y equals, and you can type this equation in. So 2x plus 4, and then we can graph it so we can kind of see what it looks like. But then we can do second graph, and it'll bring up this table, and it will give us some points that we can use to make a graph. So I'm going to do the first point at 0, 4. And then I'm going to do one, let's do the negative 2, 0, which is here. And then we'll do one more. We'll do this 2, 8. And so to make a straight line, all you need are 2 points. I normally do 3. It just kind of helps make it a little bit more exact. Ooh, I didn't get my line through my points exactly right. So there's my graph. And so we draw the arrows because this line will go on and on forever. And so when we have a straight line that goes on and on forever, the domain is all real numbers, and the range is all real numbers. So again, the domain are the x's. So again, this line will go on and on forever. It will go through every x value to positive infinity and negative infinity. It will also go through every y value to positive infinity and to negative infinity. So with ordered pairs, so this is a continuous function, goes on and on, all the points are connected. When we have a set of ordered pairs, this is a discrete function. They're not connected, so it's not going to go on and on forever. So when we're given this set, our domain are going to be all the x values. And so negative 4, negative 2, 0, 2, and 4. That's going to be our domain. So all the x values is the domain, which means the range is all of the y values. And so we just write them in a list with commas, 3, 1, 0, negative 1, negative 3. So the important thing to remember, domain are your x's, ranges are your y's. So the next one says find the domain given the range. So they've given me an equation, and they want me to find the domain. They want me to find the x's. So again, we can use the calculator to do this. So we're going to go back into y equals, and we're going to type 4x minus 6. And then we can just do second table. So again, the range, these are the y values. And so you've got two options here. You can plug all of these values in for this f of x and solve for x. But again, you can use the calculator. So I'm looking for these values in the y. So there's negative 18. There's the first one. So when I write my domain, my first value, my first x, is negative 3. So if the range is negative 18, the domain would be negative 3. So now I'm looking for negative 6 in the y's. So there's the negative 6. The x value associated with it is a 0. Then I've got a 2. So there's a 2. The x value associated with the y value of 2 is also 2. Then I've got the y value of 6. So the x value would be 3. And then finally the y value of 10, and that's associated with the x value of 4. And so that would be my domain there. The next one is a little bit different. It's the same equation, so I don't have to change anything in the calculator, but the domain, the x values are x is greater than or equal to 0, so here's 0, and x is less than or equal to 4. So from 0 to 4, that's my domain. So my range, so on this one, again, if we graph this, if we look at the graph, we can see that it's connected. And so if I would just connect these points here on the graph from 0 to 4, the x's. So from 0, and then here's 4. That's where the graph would end. I would have solid dots at 0 and then up here at 4. And so I would write my range a little bit differently. My range, so where x is 0, y is -6, and I would use the same symbols that I used in the domain. So when x is 4, y is 10, because those points through there would be connected, because it's not just the points where x is 0. It's not just these 5 points, 0, 1, 2, 3, and 4. It's all of them in between there too. 1.2, 2.5, 2.6. All right, so mappings. Mappings, we do the same way that we do the ordered pairs. So your input in a mapping is usually on the left, and sometimes they label it for you, but your input is your x and your output is your y. So again, domain are your x values, range is your y values. So my domain are going to be those 4 numbers. And I'm going to write them in numerical order. So the smallest one is -1, +1, 4, and 6. And then my output, or my range, are going to be this set of values. Again, I'm going to put them in numerical order. So 0, 4, 10, and 14. Those would be my range values. So on the next one, same exact process. X's and Y's, domain are my X's, so I'm just going to write these numbers. They're already in numerical order. Commas, with commas in between each value. Then my range are going to be my Y values, so -4, -1, 2, and 5. So I just copy the values down, and I use those brackets. All right, so from a graph, so this is the most common way you're going to find domain and range. So domain are the X's. So we can see that we have these solid dots here. So we're starting this graph. It looks at like -3. I know it's hard to see here in the video, but that is a -3, and this one here is a +3. So my domain, my X's, this graph goes from -3, and -3 is less than or equal to x, and x is less than or equal to 3. So those solid dots are why I'm using these signs. So my range are going to be my y values. So my top y value up here, that's actually a +4, and then down here this is a -3. So my range, my smallest y is a -3, less than or equal to y, and y is less than or equal to 4. So this is why we reviewed that interval notation. When we have a graph that's just a section of a line, we use that interval notation or inequality notation. So the next one, now we have an open circle. So domain are my x's. So this is a -4 here, and this one is a 3. So it's an open circle. So for my domain, 4 is less than x, and x is less than or equal to 3. That's my domain, from -4 to 3. Now my range, my smallest y here is a -3, and my biggest y is a 2. So again, open circle down here. So -3 is less than y, and y is less than or equal to 2.